So today we're going to be doing an authentication system. As an authentication would contain, right, users are able to register themselves in the system, users are able to log in, and then users are able to sign out. Now, with the note of these 3 bullets, we aren't really going to focus that much on registration, purely because registration seems like a pretty basic task. I mean, it has its own problems in itself, right? You do need to have some sort of data security on the database side. Right, so over here. Registration is not really the purpose of what we're trying to achieve. The whole point with an authentication system here is to make sure that, right, we can differentiate between Bob, who's a really good person, and a bad actor who wants to impersonate Bob. Make sure that they can't do things that Bob would be able to do, and everything that Bob is supposed to be able to do, he can do. We will discuss sign out a little bit, and right, I note that we have some implications here to consider. That typically is going to show up around talking about a decentralized authentication system. The authentication system that we're going to start with is very centralized, and we'll discuss about why that can be a good or bad thing later on. And in general, right, we just want to highlight that we're going to consider security throughout everything. So to move on, let's get started. The biggest problem with building an authentication system initially is that HTTP is stateless, right? So we need to figure out how to make HTTP stateful. Now, to remind you of what we mean by HTTP being stateless, let's look at this endpoint on the left here, our posting hi. So this endpoint hi contains, right, a body, and the body has the name of a user. The name of the user is Bob. Now, it's going to return a response that contains a message. The message is hello, Bob. Now, imagine if I want to run this again and I wanted to say times 2, right? Like however many times I ran it. So let's say I called it like 10 times. I wanted to say like hello, Bob times 10. So if I wanted to do that, the problem is that HTTP has no way to do that because it only handles one request at a time. It doesn't have any idea of what the past was like, right? Like in the past, we did write like post hi, let's say if you looked at the server logs, but the protocol has no idea of that. And that means that if we're purely using the protocol and nothing else, there's no way to achieve this times 10 feature. So how actually does this problem introduce itself in the realm of authentication?
If you're enjoying this video, we have plenty more awesome data structure algorithm and system design explanations on interviewpen.com. You can ask us any questions you have about any kind of topics surrounding data structures and algorithms and system design. We release 2 to 4 videos a week. You can run your code. You can talk to a personalized AI teaching assistant. And yeah, the site's pretty great. Anyway, enjoy the video.
Right, and let's get into talking about this login endpoint. Right, when we log in, we're going to provide the username and we're going to provide the password. The API, when we send the request to it for the username and password, right, it's going to go to the database, which is over here, and it's going to check and make sure that the username and password are equal. There's our own like hashing, salting, etc. techniques for that, but we won't really be getting into that implementation in this video. But let's say it passes, right, and we know that this is the correct credentials for Bob. So now Bob is going to be quote unquote led into the website, and when he's led into the website, he can start doing actions. Let's say, for reference, Bob is an admin. So Bob has the ability to delete users from our service. The target is the user that he wants to delete, so he wants to delete the Mary user. Now, since HTTP is stateless, we have no way of actually identifying that like Bob is sending the request, right? So what we do is in our request, we provide the username, and we just say the user Bob is sending this. We just assume that Bob has authenticated correctly, so we should be in good shape. And this works, right? Like we prevent users, like normal users who, for example, Mary tries to do this, and Mary will get denied because Mary doesn't have admin privileges. But the problem is what if a bad actor comes along, right, and they just forge a request and they say that they are Bob, right, when in reality their name is James? Now people are just doing requests on behalf of other users. So how exactly do we get past that? Getting past that, we're going to introduce the idea of a session token. The idea of a session token is to identify the difference between the bad guy and Bob, right? They're not equal. They're not the same people, and we want to ensure that Bob is able to do the actions that he needs to do, like deleting users, and the bad guy's not able to do that because he's not Bob. A session is the idea that Bob is on his own machine, and this machine is what he logged in on. This bad guy did not log in as Bob, so he does not have a session for Bob. Right, since HTTP is stateless, we need to include some sort of server-side logic in order to achieve this, right? We have to add in something other than the protocol. We have to depend on something else. What we're going to depend on is having another database. This database is going to contain a sessions table. And this sessions table has a user to a session ID. Here the session ID is XF1DE. Whenever Bob is going to log in, the API is going to generate the session ID, which was XF1DE, and it's going to put it in the database. The API needs to generate that in a secure fashion, and we'll learn about that in the next slide. But now every single request that Bob does, he's going to send his session token along the way, and then the API for every request is going to go to the database, look it up in the sessions table, and then know that the user is Bob. The reason why this works is because now the bad guy cannot just say, okay, I know that Bob's username is Bob, right? So I will impersonate him. In order for the bad guy to impersonate Bob, he needs to know Bob's session token, which is only given to Bob himself. So if Bob does not leak his session token, right? With security, humans are like the worst factor. So if Bob leaks his session token, you still have the same problem. But if Bob does not leak his session token, then the bad guy has no way of just guessing how to impersonate Bob. To look at how this flow would actually work for a user, right? We're going back to this delete user endpoint. And the delete user endpoint, remember we used to have a user here. Now we're going to change this user to be a session ID. The session ID, as you saw, is the same thing as the table before, XF1DE. And so the process is that this request is going to be sent to the API. The API is going to go to the database. In the database, we're going to look up XF1DE, and we're going to find that Bob is the user for that. Now, Bob, we know, is an admin from our database. So using that information, we can now say that we can do our action of deleting the user. If, for example, James, if he logged into the service and he sent a different session ID, we look up his session ID, find that his name is James, not Bob, and the only way to impersonate him, like I said before, is to know that Bob's session ID is XF1DE. Now there is some attack surface here, right? If I develop XF1DE in some sort of systematic manner that the bad guy is able to figure out how Bob got his session ID, then, right, he can impersonate Bob. So the bad guy needs to be able to guess well. But if we do this in a cryptographically secure way, right, if we have a secure random, generator and we generate these properly, we can ensure that there's a statistically improbable chance that the bad guy is going to actually be able to impersonate Bob from his client without having to hack Bob in the first place, right? We want to identify that. There's always the opportunity that the individual user gets hacked, right? That means that you can just change the session ID to whatever their session ID was, and then you're in trouble. But the whole goal is that we're identifying that these two users are independent of each other, right? Like Bob and James are separate from each other, and we want to make sure that the bad guy can't just magically do things on Bob's behalf. So moving on how we'll actually store these tokens, right? The default, option you'll see online and that people typically use, and it's very easy, is cookie-based storage. And if you don't know what a cookie is essentially, right, the browser has cookies. It's just like this little extra data that I can attach to a web page. And a cookie has information like, the domain that it's associated with, the duration, like how long it's going to last, and like the data that's associated with. The data would be the session token in itself. The duration, right, the cookie will expire after the duration passes. And the reason that we need the domain is because every request that the user sends, so imagine this is a little search bar up here, right? Every single request that the user sends here, if it matches the domain name in the cookie, it's going to send the cookie along with it. Now that's great, right? It makes it very easy, but the problem is that we introduce some new attacks here. Cross-site scripting attacks that are available and CSRF attacks. CSRF stands for cross-site request forgery. So imagine I send an email to the person I seek to attack, right? I'm going to give them a URL, and this URL is going to be, like bank.com/pay, right? And it has data in it that makes it so it pays me. And that's because the browser is going to immediately include those cookies. So, right, we've identified that cookie-based, right, has its own flaws, right? It's very easy to implement, but it has a lot of security flaws with it. So, right, if I'm building a very simple service, it's great to go with cookie-based session storage because it makes it easy. And it's unlikely that people are going to really be focusing on doing these attacks against your site. However, if we want to be secure in general, right, we want we want our session tokens to not immediately be sent. And that can be achieved, for example, doing it through local storage. It doesn't have to be through local storage. There are other options you can look up online. But just for this example, right, we're going to focus on local storage. So if you don't know what local storage is, right, the browser has some separate storage for each page, right? And you can store extra information here. It's a little bit more work because now we have to deliberately include the session token, for example, right, in the authorization header of a request, right? It'll be authorization, maybe it'll say bearer and then there's like a token there. So it is a little bit more work, but it means that the user needs to make deliberate request attempts, and it means that we can't do that CSRF attack like I mentioned up here. So moving on, within these system design videos, we always really focus on architectural concerns. So of course, at some point, we had to get to this point. The biggest problem we have right now is that every single time a user is going to send a request to our API, right, it has to go to the database. That means every single request has to go to the database to do at least one read, and that's to ensure that the session is valid. The endpoints you could argue that are not including in that is like login, for example, or maybe register. That means we have to horizontally scale our database, right? Or just in general scale. It doesn't have to be horizontal, right? That's your own scaling decisions. But in general, right, there's now a huge database consideration. Like, what are we going to do here as we get more and more users? In general, right, we also have to care about like a denial of service attacks. If you don't know what a denial of service attack is, just for like a basic reference, it's just somebody's going to send you a ton of packets at once to your service in an attempt of crashing it. And with that, right, we're going to do a bunch of database hits. We have to have a new concern surrounding that. Whenever these problems typically crop up in, an architectural concern scenario, we kind of go straight to some sort of decentralization. So let's look at ideally what a decentralized system would look like for authentication. It would involve the user sending a login endpoint as per usual, and there's going to be a separate login API. This login API is going to generate some sort of token, and this token is going to contain information like, the username. Maybe it's going to contain like whether, they're an admin or something like that. And then that's going to be stored on the client. Now, every single time the client wants to access a different API, they will take the information that's on their client, include it in the request, and then now this service will be able to verify that it is a token that the login API generated. And then using that information, it can do whatever it needs to do. So for example, right here, right, like the user's API has a way to see how much money a user has. So this, maybe the user that they're looking for, they want to know how much money they have. But right, the note here is that these are completely independent, right? Like in our previous scenario, we had lines drawn here, and there was one database. And that's how we were actually storing the session information. Moving on to one option and how to solve this. It is JSON Web Tokens, also known as JWTs. That's what I'll call it, and it's a much, much shorter way to speak about it, right? But I want to note that JWTs aren't the only option out there. There are other things you can do, but JWTs get, I think, the basic principles down and allow us to discuss, some of the problems that might exist, and that's why there's with caveats down here. Looking at the structure of what a JWT is. A JWT includes a header, it includes a payload, and it includes a signature. The header is not really relevant to us that much. The header just includes the encryption algorithm we're going to use and then the type of the token. The type of the token is always JWT, and that's simply there for backwards compatibility purposes. The payload is the actual application data. So like I mentioned, we need to somehow keep on the client side what the username is, right? Maybe if they're an admin or not. We also have the signature, and the signature is the biggest part of this, right? If we don't have any signature, we have no way to verify the integrity of the data. Then if this data is all that's stored in the client, I can just go back to square one, like we were talking about. I'll just say that my username is Bob when I'm actually James, right? That's like a huge concern. Now, in order to solve that, we're involving the signature. The signature is going to use the algorithm from above, and the algorithm is going to encrypt the header and data, right? It's going to provide some sort of, it's not going to directly encrypt it, but it'll provide some sort of checksum, right? And this is going to be developed using a secret. Using this secret, right? This is a secret, right? We want to keep this on the server side. Let's make that clear. So the login API will generate a JWT when it gets a request from the login endpoint. This JWT is going to go back to the client and be stored on the client like we mentioned. Now, whenever the client is going to make a request to the user endpoint, it's going to send the JWT, and it's going to use the fact that we're using asymmetric encryption to verify the data integrity. So it can verify using the signature in the JWT that the header and payload came from our login service. So even if I attempt to modify the payload, right, I attempt to say that my username was Bob. If that is true, it will fail the data integrity check, and now we can simply reject that authorization attempt. Where we have developed a decentralized authentication system, right? We really hope that we don't leak the secret and we don't leak what algorithm we're using, hopefully, right? Because if we did, we can simply just generate our own keys on the client side and never have to go to this login API and forge whatever we want, right? As I mentioned that humans are always the biggest bottleneck in security, this is a great example of it, right? But another problem I want to mention is how before, when we had this centralized service, while it did make a lot of hits go to our database, it meant that there was a centralized point that we could say, let's log everybody out. Right now, every single time I do a login, well, let's say the login API also handles logout. Whenever I do logout, I can do some sort of state change in my database, for example, right? Like let's say, there's some sort of status, like whether I'm online or not. That can change. But the problem is if the client wants to keep this JWT around, it will continue to exist. And so then they can just use it on the user's API for as long as they want, right? And typically a solution to this is it includes some sort of like duration in the payload. With that, right, we can say if like the current time, right, if the time is greater than the duration timestamp, then we can reject this JWT as a whole. But until that point, this user's API is just kind of forced to accept it without any like central point of truth. That was the benefit that we had here in having a central source of truth. So now, right, we're done. That is the general concept of authentication, right? Authentication is a system in itself. In general, you could argue that it's a rather simple system. It can also be argued to be complex in different ways as well. But it's good to, right, understand that we need to have state in order to have authentication, right? That's a huge point, a point to bring up in an interview when you're discussing authentication of your service. And maybe you start designing a large-scale system. Maybe you're developing a microservices architecture and you want to talk about how, right, we need to have some sort of decentralized authentication. That way we won't place so much load on our database and won't have to scale our database to, support like tons and tons of read requests simply because we're checking a login endpoint, for example. Finally, right, security is always the biggest concern with this, and you want to keep your head in the mindset of that any data that you place in the hands of the user, right, if the user has information on their client, right, their little machine, that means a bad actor has the opportunity to intercept or modify that on their machine. Getting around that involves, right, taking into account like making sure you're using HTTPS. I mean, there's a reason why you should use HTTPS. If you don't understand that point, I would definitely look it up. As well as just considering in all of your security decisions that you're ensuring that you very rarely trust the client with the information that they're providing. Overall, right, that is how you design a basic authentication system, and I hope that this can help you in your interviews in the future.
If you enjoyed that video, you can get a lot more content just like this on interviewpen.com. We publish 2 to 4 videos a week. Really, it's just an arbitrary number. It's whenever I can sit down and do a video because these videos take a whole day to do. And we're always online to answer any questions you may have. Join our Discord, join our newsletter, The Blueprint, where you can get more weekly data structure and algorithm and system design kind of topics. And subscribe and like this video if you actually like this video and it helped you. And also tell a friend that we exist. That's all.